A transversal is a line which intersects two or more lines at distinct points, and if a transversal falls on two lines which are parallel to each other, we get four angles at each point which consist of a pair of corresponding angles, alternate interior angles, alternate exterior angles and interior angles on the same side. Of these, the corresponding angles will be equal to each other. Alternate interior angles will be equal to each other and interior angles on the same side are supplementary. We have axioms and theorems for that. What about lines parallel to the same line? Do we have any axiom or theorem for that? Let's check it out. Consider a line, say L. Now consider another line M such that M is parallel to the line L. Now consider yet another line N such that N is parallel to the line L. So here we have two lines M and N which are parallel to the same line L, and thus we need to find out whether the lines M and N are parallel to each other. That calls for a proof. So let's try to prove it. For that, we need to draw a transversal, say T, on these three lines. So we have the corresponding angles formed as angles 1, 2 and 3. Since the line M parallel to N and the line N is parallel to L, their corresponding angles are equal. That is, angle 1 equals angle 2 and angle 1 equals angle 3. So angle 2 equals angle 3, which are the corresponding angles of the lines M and N respectively. Hence the lines M and N are parallel to each other, hence proved. This result can be stated as a theorem, that is, lines which are parallel to the same line are parallel to each other. That is, this theorem is not only applicable for two lines but also extended to more than two lines. Now let's work out a problem. In the figure, if AB parallel to CD and CD parallel to EF and Y is to Z equals 3:7, find X. Since AB is parallel to CD and CD is parallel to EF, AB will be parallel to EF. That is, lines parallel to the same line. So the alternate interior angles, angle X equals angle Z. Let's consider it as equation 1. Given Y is to Z equals 3:7. Let the common ratio be A. So angle Y equals 3A and angle Z equals 7A. Also, since AB parallel to CD, the interior angles on the same side, angle X plus angle Y equals 180 degrees. Let's consider it as equation 2. Substituting equation 1 in 2, we get angle Z plus angle Y equals 180 degrees. Substituting the values of angles Z and Y, we get 7A plus 3A equals 180 degrees, which implies that 10A equals 180 degrees, that is, A equals 18 degrees. So angle X equals angle Z equals 7A, which is 7 into 18, that is 126 degrees. So we can conclude that for lines parallel to the same line, we have the theorem lines which are parallel to the same line are parallel to each other.